Hi, welcome to the Pre-Calculus lecture series. And today we're going to talk about the section 2.6, transformation of functions. So what is this section? We're going to talk about is how do we, the graph the function without physically we need to pick the points. And so we're going to see how can we graph the function by starting with the functions, parent functions, and then apply the different transformations to the parent function, and then how do we graph it, okay? And this section is a little bit longer than the previous sections. So we will, divide these sections into the two videos, so we don't study in the one video too long. It's kind of like it's then we're getting boring there. Okay, so now let's go to our note about these sections here. So the first things here we're going to talk about is the vertical shift. That means if your graph moving up and down, all right? So the vertical shift is here. So in here we say if we have the constant c greater than 0, then the graph, right? So the graph y is equal to the f of x plus c, and shift the graph f of x, okay? Oh, maybe it's here. So shift the graph y equal to the f of x upward, c units. Then, so the same here, the graph here, y is equal to the f of x minus c. Then we shift the graph y equal to the f of x downward, c unit, right? So here is the key things. So if it's a minus, you shift downward. If it's a plus, you shift upward. Of course, here we assume the c is greater than 0. Okay, because it's like the f of x plus, so that's why it's the vertical shift here. So let's take a look here. So like in here, okay, so if you have a functions here, so let's say here, this is my functions here. Okay, so if this is my f of x, then if you have a new functions, f of x plus c here, right? So that means your function going to shift upward. That means all the values are going to, add c's here. So that means that the distance from here to here is c. That means this one's here, this is f of x plus c, right? That means your whole function shift upward here. So the same things here, right? So in here, if you have a function here, so let's say here, so if I have a function like this is my f of x here. And then I have another function. So here go like this. And then this distance is c. Then this is, we call it shift downward, right? So it's f of x minus c here. Okay, so it's pretty straightforward, right? So you add something to your y because the f of x is here, because f of x is y, right? So when you add something, then you move the y value up and down, right? Okay, so now let's take a look at these examples here. So this example, so they said, okay, we talk about y equal to the x squared. This is the quadratic functions, right? So this is the parent functions. So in order to do this, so typically it will be easier for you to graph instead of just randomly draw. So in here, you put your parents' functions here. This is the f of x is equal to the x squares, right? Okay, so now you start with the first point. You say, okay, how about the x equal to 0? Then this is zeros, right? And then when x equal to 1, so 1 square is what? Is 1. Then x equal to 2, what is here is 4, right? Okay, so now I go to negative, so x equal to negative 1, what is here is 1. And then when I go to the negative 2, what is here is 4. All right. Okay, so I have 5 points, and these 5 points can help us and try to draw. So okay, so I have the 0, zeros, right? So this is my first point. Then I have 1, 1 here, and the negative 1, 1. Then I have 2 4s here, right? So I have 2, 4. I have a negative 2 and 4. So the way, I would like you guys to draw this is like when you do the parent function, because this is not the final function I want, right? So draw the dotted lines here, right? So this dotted line here. Okay, so this is not this is what my parent function looks like. Okay, so now let's take a look here, right? So now I'm going to use the red to the gx, x squared plus 3. So based on this 5 points, so the first point is 0, 0. Then y add 3. So what happened to y? Y going to be here, right? Okay, this is 1, 1. So add 3. So I'm from here, go up 3. 1, 2, 3, right? So it's here. So the same ones here, this is negative 1, will go up 1, 2, 3, so it's here, correct? Okay, now the next ones here, this is 2s, right? So 2, I go up 3, 1, 2, 3 is here. So here, negative 2, I go up 3, right? So it's here, 1, 2, 3 is here, right? So now you can graph it. So this is your right? So this is your gx, correct? Okay, so that's why I say if you have, if you have this one's kind of graph it, try to graph on, on the whiteboard is really difficult. Okay, so here, yeah, that's much better. Okay, so that's why I say if you have those points, you select add a parent function. It's a lot easier for you to guide your graph here. Okay, so now let's take a look at x minus 2. I'm going to use the green. Okay, so the same way is here because it's minus 2, right? That means that the y going to going down. So the first, this point is 0, 0, right? Go down. So this point go to here, correct? Then the next ones here is 1, go down 2, 1, 2. So this point go to here. Then this ones here go down 2. So it's 1, 2. This point go down here. All right, now let's take a look at this ones here. This is 2 and 4, go down 2. So it's 1, 2. So this one drop down to here, and then this one drop down to here. Okay, so now with those 5 points here, then you can graph. So this will be, so this will be my h of x here, right? So that's why I said you always, to keep together a good graph, you always kind of start with your parent function, then work with the transformation about your parent functions here, right? Okay, so that's good. And now let's take a look. So here, right? So the verticals here is f of x, right? So be careful. This is what is f of x. Y is f of x, right? So that's why is the y value going to go up and down, correct? Okay, so now the next thing here we're going to talk about is the horizontal shift here. So the horizontal shift, so it's the same things here. So let's say here c is greater than 0 here. So we say the graph, so the graph y is equal to f of x minus c is a shift graph. Y equal to the f of x Okay, so that's the y equal to the f of x here to the right. Okay, so also we know the graph here. So the graph y is equal to the f of x plus c here. So it's a shift the graph y equal to the f of x to the left, c units. Okay, so basically you want to see what is the shift right or wrong, right or left, right? So basically you just like the set, you know, the in here equal to 0, then solve for x. So like this one, x is c, right? So that's why you shift to the what? You shift to the right. So now in here, this is x plus c, right? So if it's x plus c, then when you set it equal to 0, x equal to the negative c. What is means negative c? That means go to the left-hand side, right? So that's why it's a shift to the left here. Okay, so let's take a look of what is the graph going to look like. Okay, so now let's see here, like I have some graph here. So this is my f of x, right? So now if I shift to the right, that means I have a, oh, hope I do that. Okay, okay. So this one's here. That means this is the f of x minus c. That means from here to here, right? So it's c units. So it's the same distance this way, right? So it's a c unit. And now the same way, so from shift to the left here. So if this is my function here, so if this is my functions here, so if this is my f of x, shift to the left, that means you go in here, right? So this is the function I call this f of x plus c. That means from here to here, you shift to the left, c units here, all right? Okay, so that's what we call it is the shift to the right. It's a horizontal shift, right? Okay, let's take a look at this problem here. This problem is f of x equal to the x squared. Okay, so now if you see here, you say, oh, this is x plus 4, and this is x minus 2 here. Okay, so as always, because the parent function here is x squared, right? So let's write it down. The few points will help us. So this is f of x equal to the x squared. So hope this one can help us to, to graph here. So we have 1, 1, 2, 4, then negative 1, 1, and the negative 2, 4. Sometimes I call those are the fundamental points or the basic points for the parent function, which can help you to draw here, right? So as always, okay, let's start here. So let's draw. So the first one is 0, 0, 1, 1, 2, 4. We did this. And 2, 4, right? Since this is a parent function, so what I use the dot lines, right? So I'm not using the solid line. So this is the function I need to start with. Okay, now remember, right? We say x plus 4, what's that mean? So x plus 4, so you set x plus 4 equal to what? Equal to 0. That means x equal to the negative 4. That means you move to the left-hand side. 4 units, right? So that means you move to where? You move to the left, right? Okay, so that means x equal to move to left here. Okay, so now let's take a look at these ones here. The first one, okay, so 0, 0. This is a 0, 0, right? So you move to the left, so it's 1, 2, 3, 4. So you only move the x value and nothing to do with y values, right? Okay, so now for these ones here, this is 1, 1, right? So you move to the left 4 units. It's 1, 2, 3, 4. So this point move to here. Okay, so this point here, so 4 units is 1, 2, 3, 4. So this point move to here. Y is not changed, right? Okay, now this value, this point here, see where we move to is 1, 2, right? 1, 2, 3, 4. This value move to here. Then this value is 1, 2, 3, 4. This value move to here. Right, so now that's what I said. I try to write down those basic points are very, very helpful when you try to graph. Okay, so now I can connect it. Okay, so this is my g-axis here. Even my graph is kind of crooked a little bit, but you can see what I mean here, right? Okay, now let's take a look at the other ones here. The h of x is x minus 2. So your x minus 2 equal to 0, so x equal to 2. So that means you shift to what? You shift to the right 2 units, right? So you shift the 2 units to the right. Okay, so now let's see here. So this point is 0, 0. I shift to 2, so this will be here. Okay, this point of 2 units, 1, 2, so shift to here. This point is here is 1, 2, so shift to here, correct? Okay, now this point I need to shift 2 units, 1, 2, so it's go over here. And this one is 1, 2, so it's go over here. You see that? So that's why you need to have those basic units to help you to decide where is your graph shift to. Okay. Okay, so this is my h of x, and that is what I mean. The horizontal shift here. Okay, now let's take a look. Okay, so example number 3 is a combined 2 skills we learned so far. Is the vertical shift and the horizontal shift. Oh, wow, so I have the square roots, right? So now I know my basic functions here, my parent function. If I want to start, so my parent function will be the square roots of x here. Okay, so let's choose a few points to see it will help us to do the graph here, right? So this is x, and this is the square roots of x, right? So when x equal to 0, f of x equal to 0. Okay, so x equal to 1, this is 1, right? Then let's choose some other good points. So x equal to 4, what is the square root of x is 2. X equal to 9, what is the square root of x is 3. Okay, so those are the 3 good points can help us. So let's start here. So 0, 0 is here. 1, 1 is here, right? Then 4, 2 is here. Then 9, 3 is here, right? So this is my parents' functions here. So go boom, 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 boom. Okay, so I go boom, 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 boom. So I put the dot lines here. Okay, so now, just like the order of operation, so the next thing here, we want to see, hey, this is x minus 3. What's that mean? That means x minus 3 equal to 0, you will get x equal to 3. So what's that mean, x equal to 3? You will shift to what? You shift to right, correct? 3 units. Okay, so now let's try to take a look at this transformation. Shift to the right 3 units here, right? So this point is going to do, go to here, right? Okay, so the second point, I think I did not. Okay, so second point is this point, right? So this point and this point. Okay, so the second point is this one going to shift to 3. So it's 1, 2, 3. So it's going to shift over to here. Okay, this point is 4, 2, shift to 3. So it's 1, 2, 3. So this point is going to shift to here. This point is 9, 3. So shift 3, 1, 2, 3. Oh, it's out of the scales here, all right, but fine. And so this is the transformation of the minus 3. So this is not the final function yet. So we still do what? Dot lines here. So this dot line taking care of the horizontal shift, right? So this is a horizontal shift, shift how many? 3 units, right? So shift to the what? Shift to the right. right? The 4 units here. Okay, now the last operation is, hey, I need to plus 4. Okay, so that means every point from the red one, you need to plus 4. Okay, so this point here go to 4. 1, 2, 3, 4. So this point is shift over here. Right, so then this point here, add 4. 1, 2, 3, 4. So this point is shift to here. Then this point add 4. 1, 2, 3, 4. This point is shift to here. Then this point add 4. 1, 2, 3, 4. This point is shift to here. Okay, so now because this transformation, then I complete the whole transformations of these functions, right? So now I can graph it. Okay, so now I can graph it with a solid line. So, okay, so this is my functions here, right? So this is a finished product. So this is the function of, so these functions here is the f of x equal to the square root of x minus 3 plus 4. All right, so that's what you do here. That's, that's what's the functions, right? So you start with the parent, then you do one transformation at a time. So if it's not a final function, you put the dotted line. That means I'm still working. So finally, when you finish all the transformation, your final product, you use the solid line to represent that. Okay, so now let's take a look at the reflecting, all right? The reflecting here, okay, so the reflecting the graphs here. Okay, so the graph y, how about if you have a negative sign in front of it? That means that the y going to switch, right? So that means this one here is reflect over refract the graph y equal to the f of x in the what? In the x-axis, right? Because the value of the y, the positive to negative or negative to positives, right? So the same ways here. So the graph, how about if instead of the outside, I have the inside, the function, I have something to do with x here. Then this one here is reflect the graph y equal to the f of x in what axis here? In the y-axis, because you switch, right? So you switch here, so be careful here. So you switch the x, right, to the negative axis. So that's why they flip over the y-axis. Then for this ones here, right, you put the positive, you switch positive to negative. That's why you flip over what? X-axis here, all right? Okay, so now let's take a look at what do we mean, the graph here, right? So in here, if, okay, so if in here, I have a graph here, okay? So my original graph, let's say here, my original graph is like this. This is f of x, this is my x-axis, this is my y-axis here. So reflecting over the x-axis, what means reflecting mean? The reflecting is kind of like the concept of mirror, right? You reflect over the mirror. That means you treat the x-axis kind of like a mirror. So you kind of reflect this line. So what is this one here going to be? Right? Okay, so that's why we say this is negative f of x. Right? So every positive value, you flip it with the negatives here, right? So this is, so like let's we said it's kind of like the mirror images here. All right, so now let's take a look at what is reflecting over the y-axis here. Okay, so this is x, this is y. So the reflecting over the y-axis. So for example, this is my original functions here, f of x here, right? So what is the reflecting over the y-axis? So it's the same concept as the mirror, right? So of course, I did not draw very nice here. Okay, so let me try again. Better, right? So it's the same idea. That means right now your mirror is the y-axis here. So this function here is f of negative x, right? So it's kind of like obvious, right? So in here, that's why we said that this part is a positive x, right? So that's why this one is negative. That's why it's reflecting over the y-axis. So the same is in here, right? Because this one is the positive y here. So that's why you're reflecting over the negative here. All right. Okay, so now let's take a look. Okay, so let's take a look. Next graph here. Okay, so now I'm going to sketch the graph of y equal to the negative x squared. Okay, so remember this is the parent function of x squares, right? Okay, so I have a 0, 0, 1, 1, 2, 4, and also I think we get so good at negative 2, 4, right? So those are my values here. So let's draw the parent function first. So always draw the parent function. So it's 0, 1, 2, 4, negative 1, 1, 2, 4. Okay, so then this is my parent function. So what kind of the things I'm going to use? The dot lines, right? So dot lines here. Okay, now I say, hey, everything right now I have negative. That means I'm flipping, right? So I'm flipping it to the what axis? X-axis. So this point already on the x-axis, so I don't change that. So it's here. Then this one's here is 1, 1, then boom, I flip down, right? So I flip to here. This one I flip down. So this one is 4 units to the x-axis. So I need to flip down 4 units to the x-axis here. So this is the same way. So I flip down to here. So this is my final graph here. So that's why I can use the solid line to do that. So this is the f of x is equal to the negative x squared. All right. Okay, so now let's take a look at this ones here, right? So the gx is negative x square roots. Okay, so now let's take a look at our parent function is x and the square roots of the x here. Okay, so now the square roots of the x, so the 0, so this is 0, we did it before, so 1, 1, 4 what? 4, 2, right? And 9 is what? 9, 3 is here. Okay, so now let's try to do my parent function first. I think right now after that you should be pretty good. You already know how to do all this, all right? So 0, 0, 1, 1, 4, 2, 4, 2, see here. 9, 9 is here. 9, 3 is here. Okay, so this is my parent function. So I do a dot, 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 dot. Okay, so I do a flip. Right now, because the flip is negative x, so that means that I know I'm flipping over to what? Y-axis. So this point already on the y-axis, so stay the same. So this one here is 1 unit away from y. So when I flip, what? Boom, I flip over to here, right? So this is like 4 units, right? So I boom, I flip over to here. How about this man? This one's here. How many units? 9 units, right? So I flip over to what? I flip over to here, right? So now I can connect it. Okay. So this is what do we call it? It's a gx is equal to the negative x here. All right. Okay. So now I think right now is good place to stop and our first video, and then we're going to take a look at our second video. We're going to talk about another 2 transformation is vertical stretch and shrink, and also is the the horizontal shrink or stretch here. Okay, so right now is a good time and for the video number 1 here. Okay, so nice to talk to you and look forward to talk to you in our next videos here.